This video is going to be on section 4.1, which is probability distribution function, a PDF for a discrete random variable. So, our chapter objectives. By the end of this chapter, you should be able to recognize and understand discrete probability distribution functions in general, calculate and interpret expected values, recognize the binomial probability distribution and apply it appropriately, classify discrete word problems by their distributions. So a little vocabulary for our probability distributions. A random variable is a variable whose values are determined by chance. So that describes the outcomes of a random variable describes the outcomes of a statistical experiment in words. The values of a random variable can vary with each repetition of an experiment. We use the uppercase letters, usually X or Y, to denote a random variable, and then we use the lowercase letters X or Y to denote the value that the random variable can take on. So if uppercase X is a random variable, then uppercase X is written in words, and lowercase x is given as a number. A discrete random variable is a variable that can only take on a finite number of values or a countable number of values. An example would be like the number of students in a statistics class. You could have 15, 25, 30, 250 students in a class, but you couldn't have 25.5 students in a class. So in class, we're going to do an example with discrete random variables for a coin toss. For this video, we're just going to move on. So a continuous random variable is a variable that can take on any of the countless number values on a line interval. So all the in-betweens, the decimals, the fractions, the parts. An example of that would be the air pressure in an automobile tire. And that can take any value from 0 pounds per square inch to whatever the bursting pressure of the tire is. It's different for different kinds of tires. So you could have 20.126 pounds per square inch or 20.12678 pounds per square inch, etc. So a probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of the values if you're working with a continuous random variable. A PDF for a discrete random variable has two characteristics. Each probability is between 0 and 1 inclusive, so that means it could be 0, could be 1, and the sum of the probabilities all add to 1. So a discrete probability distribution can be shown using a graph or a table. In that coin toss example, we made a table of all the different heads we got when we flipped a coin, and that can be considered an example of a probability distribution function. It can also be thought of as a relative frequency distribution based on a very large n, like how many times you do it. So an example, or try it 4.1 from the book. A hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. So here's a table with some information. So let X, our random variable, be the number of times a patient rings the nurse during a 12-hour shift. And for this exercise, X can take on the values 0 through 5. So that's the number of times that the patient can ring the nurse. So here in our table, we have those numbers listed, and then we have a column with the probabilities listed. So 4 out of 50 times a patient rang 0 times, 8 out of those 50 patients rang 1 time, 16 out of the 50 patients rang twice, etc. So P of X is the probability that our random variable, uppercase X, takes on the value lowercase x. And then why is this a discrete probability distribution function? Well, it's because each probability is between 0 and 1, as you can see, and the sum of the probabilities, if you added them up, you would see they all equal 1 if you add them all up. So sometimes we're given a probability distribution function, and so we know that they're going to add up to 1. Sometimes we do an experiment and we realize that, I guess, it's always going to add up to 1 unless you have something else going on where you're double counting things. Another example, suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days, 15% of the time, 1 day, 4% of the time, and no days, 1% of the time. And suppose 1 week is randomly selected. So let X equal the number of days Nancy, and we're going to define that variable. Then we're going to talk about what values our random variable can take on. And then we're going to choose 1 week at random, and we're going to construct a PDF like the one we just saw with 2 columns, one for the values that our variable can take on and one for the probabilities. So how can we define our variable? We're going to let X be the number of days that Nancy attends class per week. What values can X take on? Well, we know from the information she has class 3 days per week, so any of the numbers between 0 and 3. And then to do the probability distribution table, you can go to Excel, and I've made an Excel sheet for us, and we can put in those values 0, 1, 2, and 3. And then we can put in the probabilities that we have from the information on the slide. So she attends class 3 days a week, 80% of the time. So for 80%, we would type in 0.8. That was a 3 days per week. Oh, see, something to be careful of. Make sure you are going in the right direction from your problem. So 2 days per week is 15% of the time. So 0.15. 1 day is 4%, 0.04. Always be careful of those single digit percents and make sure you have 2 decimal places. And then 0 days is only 1% of the time, so 0.01. Now, if you're not sure, you can always do a sum function and add up your probabilities and see that it adds to 1. So that's good. So each one of these numbers in this column is between 0 and 1, and the total sums up to 1. So that's our probability distribution table. And we know that the column P of X, our probability column, adds to 1. So I also made a relative frequency histogram. And so just to show you, the height of the bar over the score, or the days she attends class, represents the probability of that score or days number data value happening. Okay, so 0.8, and for 3 days a week. So continuing on with this example, we want to know, what is the probability that Nancy attends class exactly twice? What is the probability she attends class at least once? And what is the probability that she attends class more than once? So this is, now that you have your probability distribution table, how can we use it? So if you look at the table exactly twice, you're going to go to your X column. You're going to look for the value 2, and you're going to go over there to the probability. Now, it's all listed up in the description, but if you had a lot of them, or we're going to get into different functions that give us those probabilities, you would look in the table for that information. So the probability that X equals 2 is 0.15. At least once, what does at least once mean? So that means once, twice, or 3 times per week. So we want to look at our probability table, and we want to add up those 3 values. So if we wanted to, we could go to Excel and we could say, okay, what's the probability that X is at least 1? So that's going to be greater than or equal to. So this is me just cheating and putting in the greater than or equal to. You can also go up here to Insert, over to Symbol, and find the greater than or equal to symbol. It's in the math section of that insert box. And so greater than or equal to 1 is going to look like that. I don't know why the 1 got bigger. That's weird, but I'm going to sum up all of the 1s, the 2s, and the 3s, and I'm going to get a probability of 0.99. It's also, 1 minus that she doesn't go for the week, so you could do 1 minus the 0.1 as well. Whatever sort of, again, makes the most sense to your brain. So as you can see, I added up all of the for 1, for 2, and for 3 to get the 0.99, or you could do 1 minus the probability she attends less than once per week, 1 minus 0.01. And what is the probability that she attends class more than once? So again, statistics, always read the problem carefully. More than once means 2 times or 3 times. This does not include going once. So we're going to add up the probability she goes twice plus the probability she goes 3 times. And we get 0.95 for that probability. So another example, Jeremiah has basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends one practice. 2% of the time he does not attend either practice. What is X, our random variable, and what values does it take on? So we're going to define our variable, we're going to say what values it takes on, and we're going to construct a probability distribution table like we did for Nancy. So X is the number of days Jeremiah attends basketball practice per week. What values can that random variable take on? 0, 1, or 2. And then jumped ahead. This is what our probability table looks like. So again, we could go to Excel and fill it all in, but you're going to put your X values, the values that your random variable can take on, in here in the X column, and then you're going to put in the probabilities. So we know that 90% of the time he goes twice. Keep touching at the screen by accident. Excuse me. Once, he goes to practice once 8% of the time, and he goes to practice 0% or 0 days a week, or 2% of the time. And then if you sum them up, they add up to 1, so you know you did it all right. So anyway, so now we are all done with section 4.1. The next video will be on section 4.2.